This is the pre-AP retake practice for Unit 4, for the Unit 4 test. Before we get into this, just to make sure you understand that the questions on this review are not necessarily a question for question example of what will be on the test. This is an idea of some of the type of questions that'll be on there, but you can have questions that range from things covered in our notes, in your practice packet, or on the quiz, or even the test that we just had. Those type of questions. Okay, so the first ones that we have are solve the radical equation. So when we're solving these, what we want to do is first isolate the radical. The radical is that root. So to get this alone, I'm going to subtract 30 from both sides. So I have 5 square root of x minus 8 equals negative 30. And then I need to divide both sides by 5. So I have the square root of x minus 8 equals negative 6. Now that that square root is isolated, I can raise both to the power of 2 because a square undoes a square root. So I have x minus 8 equals 36. And then I add 8 to both sides, and I get x equals 44. Now, the thing you have to do here, though, is you have to check your answers. You got to check and see, does this work in my original equation? So when I plug this back in, I have 44 minus 8, which is 36. The square root of 36 is 6. 5 times 6 is 30. 30 plus 30 equals 0. That's not true. So this does not work. Therefore, this has no solution. Okay, looking at problem number 2. I have 1 equals the cube root of negative 1/2 x minus 6. My radical is already isolated. It's already here all by itself. So I can just immediately start by raising to the power of 3. Now 1 to the power of 3 just keeps me at 1 equals, and when I raise to the power of 3, it gets rid of that cube root. So I have negative 1/2 x minus 6. Now I'm just solving for x. So if I have negative 1/2 times that, I need to multiply both sides by negative 2. So I've got negative 2 equals x minus 6. And then I add 6 to both sides. I get x equals 4. And I need to check that, plug it back in. So if I've got 4 minus 6 is negative 2. Negative 2 times negative 1/2, or negative 2 divided by negative 2 is 1. The cube root of 1 does in fact equal 1. So that works as a correct solution. For question 3, I need to get the radical isolated, so I need to subtract 2 from both sides. So I've got the square root of x plus 10 equals x minus 2. When I square both sides here, I need to actually FOIL this right side out. I need to do x minus 2 times x minus 2 to do that squaring. So when I FOIL that, I do x times x, which will give me x squared, x times -2, which will give me minus 2x, -2 times x to be another minus 2x, and -2 times -2 to be plus 4. I now need to combine all my like terms. So I'm going to move everything over to one side. So I've got x squared minus 5x minus 6 equals 0. The reason I want to set this equal to 0 is because I have an x squared. So the way I need to solve this is by factoring. So I'm looking for two numbers that multiply to give me -6, but when I add those two numbers, it's going to give me -5. So that would be -6 and +1, meaning my factors are x minus 6 from that -6 and x plus 1 from that +1. Now I set each of those equal to 0, and I get x equals 6 and x equals -1. But I need to check the answers, make sure that that works in there. So I plug 6 in. 6 plus 10 is 16. The square root of 16 is 4. 2 plus 4 is 6, which is what that would equal. So that one works. If I put -1 in, -1 plus 10 is 9. The square root of 9 is 3. 2 plus 3 does not equal -1. So this one is an extraneous solution. So the only solution I have here is x equals 6. For question 4, it's very similar to question 3, where you're going to need to actually do the foiling of this when you square both sides. So I end with x plus 3 equals, when I square and FOIL that, I get x squared plus 2x plus 1. I'm going to move everything over. So I've got x squared plus x minus 2 equals 0. So I'm looking for two numbers that multiply to give me -2, but add to give me +1. That's going to be +2 and -1. So if I set each of those equal to 0 to solve for x, I get x equals -2 and x equals +1. And when I plug these back in to check those, I put -2 in. -2 plus 3 is 1. Square root of 1 is 1. But on this side, I have -2 plus 1, which is -1. 1 does not equal -1. That one is an extraneous solution. I put 1 in. 1 plus 3 is 4. The square root of 4 is 2. 1 plus 1 is 2. So this does work, and that is my solution. Okay. For 5, 6, and 7, we are looking to list the transformations and also find the inverse of these functions. We're going to start by just listing the transformations of each of these three problems, and then we will go finding the inverse of each of these three problems. So for 5, to find the transformations, this negative in front is a reflection over the x-axis. A 1/2 out in front is a vertical shrink by 1/2. everything that is outside of the function being this root, that is going to be a vertical change. So that's why this is a vertical shrink. On the inside, I have this -4, which everything inside does the opposite. So this is actually moving right 4. And this +3 is back on the outside, so that's a vertical change again, and that one goes up 3. Okay, for 6, the 3 out in front here, again, because it's in front, it's not under the radical, that's a vertical change, and this number is greater than 1, so that makes it a vertical stretch. By 3. The negative under the radical, that reflects it over the y-axis. Now this +5 is actually misleading, because in order for us to see the real h value, we need to factor out any a value that's not 1, even if it's negative. So this is really 3 times the cube root of negative x minus 5, pulling that negative out from the negative x and the negative out from the +5. So now that it is -5, I can see that this actually shifts right 5. And the +7 that is outside at the end, that's going to be a vertical. And since it's positive, it's going to go up 7. Looking at question 7, here you'll notice that my b value is already factored out. So I'm not going to need to pull anything off from this 2. That's going to be my actual h value. A negative underneath the radical gives a reflection over the y-axis. The 1/4 underneath, under this radical, everything is horizontal. So this is a horizontal stretch or shrink. And because it is a fraction, that is going to be a horizontal stretch by the flip of that fraction. So a horizontal stretch by 4. This +2 that's still under this radical makes it go left 2. And this -6 that is at the very end outside of that radical, that's going to move it up and down. Since it's negative, it goes down 6. Okay, now looking back at these, to do the finding the inverse of each of these functions. So, question 5, this function is a square root function. Square root functions mean you are going to need to have a domain restriction. So we're going to need to keep that in mind after we find the inverse. To find the inverse, you switch x's and y's. So this is x equals -1/2 square root of y minus 4 plus 3. And then you go peeling away the layers, solving for y. So I subtract 3 from both sides. So I have x minus 3 equals -1/2 square root of y minus 4. To get rid of this -1/2, I need to multiply both sides by -2. So now I have negative 2 x minus 3 equals the square root of y minus 4. Now that I've got the square root alone, I can square both sides. So when I square this, I'm going to square the entire thing here, including that negative 2. So I have negative 2 times x minus 3 all squared equals y minus 4. The last thing to do to solve for y, I need to add 4 to both sides. So I end with y equals negative 2 x minus 3 squared plus 4. Now, because this was a square root function, I must have the domain restriction. The domain restriction comes from the range of my original function. So I need to know how this moved up and down and which way it opened. Did it open up or did it reflect to now open down? So this plus 3 took it up 3. So that's the value I'll be dealing with. I've got x, and I've got 3. Now to know if I want x values that are greater than or equal to 3 or less than or equal to 3, I need to look at which way this opened. The negative took it and made it open down like that. So I want any values that are less than 3. So this is my inverse for x values that are less than or equal to 3. Okay. Looking at 6 to find the inverse of this, we still switch x and y. So now it's x equals 3 cube root of negative y plus 5 plus 7. Now, this 3 here just tells me the type of function that it is. This is a cube root function. For a cube root function, you do not have a domain restriction. So for this, all I need to do is find the inverse. I need to solve this for y, and I will not have a domain restriction. So I need to subtract 7 from both sides. X minus 7 equals 3 cube root of negative y plus 5. And then divide both sides by 3. So I have x minus 7 all over 3 equals the cube root of negative y plus 5. To get rid of that cube root, I need to raise it to a power of 3. So it's x minus 7 over 3 all cubed equals negative y plus 5. So I need to subtract 5. So I've got x minus 7 divided by 3 cubed minus 5 equals negative y. To get this to positive y, I need to change the signs. When I change the signs, I'm changing the sign of this and this. I'm not going to change the sign inside of this cube because I'm treating all of this as one part. So you get y equals negative x minus 7 over 3 cubed plus 5. Okay. And looking at number 7, Once again, this is a square root function, so I'm going to need to have that domain restriction. So I'll need to keep that in mind when I get to the end. So I've got x equals the square root of negative 1/4 x plus 2 minus 6. Sorry, this should be a y plus 2, because I'm switching the x's and y's. Okay, now I'm moving everything to solve for y. So I need to add 6 to both sides. X plus 6 equals the square root of negative 1/4 y plus 2. Now the next layer is the squaring. So I have x plus 6 all squared equals negative 1/4 y plus 2. To continue solving for y, I need to multiply both sides by negative 4 to cancel out that negative 1/4. So I've got negative 4 x plus 6 squared equals y plus 2. Then I just subtract 2, and I've got y equals negative 4 x plus 6 squared minus 2. Now I do need to remember that I need to know the domain restriction on this. The domain restriction here, it shifted down 6, and yes, it reflected, however, it reflected over the y-axis. So it's still going to open up, it's just opening up and to the left is the way that it is going. That means my range is still from negative 6 to infinity. So I want x values that are greater than or equal to negative 6. So there would be your inverse function for 7. For 8, 9, and 10, we are applying the exponent rules to simplify these problems down. So the exponent rules say when you are multiplying, coefficients are still going to multiply. So I still need to do 3 times 4. So in my numerator, I will have 12. When I am multiplying my bases that are the same, that have exponents, I add those exponents together. So for x's, I have negative 1 plus negative 3, or negative 1 minus 3, which is going to be negative 4. So it'll be x to the power of negative 4. For the y's, I have y. There's no given exponent on that. And if it's not given, the assumed exponent then is 1. So I have 1 plus 5 to be y to the power of 6. That's what's on top. In my denominator, nothing here is going to combine up. It's just 24 x squared y to the power of 8. Now the next thing we need to deal with are the negative exponents. A negative exponent says whatever that exponent is on, it needs to change locations. Whether it's on top and negative, it needs to move to the bottom. If it's on bottom and negative, it needs to move to the top. So this x to the power of negative 4 needs to move to the bottom. When I do that, it is only the x part that's going to go down to the bottom. So now it is 12 y to the power of 6 over 24 x squared. When I move this down, that value stays, but it's no longer negative. So x power of 4, y power of 8. Now those x's are multiplying, so I add their exponents. 2 plus 4 gives me 6. So I have 12 y to the power of 6 over 24, x to the power of 6, y power of 8. The last things we need to do are now the division parts. Coefficients will divide normally. 12 divided by 24 is 1/2. So I still have my fraction. I've got a 1 on top with a 2 underneath. X's, I don't have any x's on top, so I'll just keep with the x power of 6 on bottom. For y's, I have y to the power of 6 on top, y power of 8 on bottom. When you divide, and you have the same base, you subtract those exponents. And since the larger one is on bottom, it's going to stay on bottom. So 8 minus 6 gives me 2. So the answer for 8 is 1 over 2x to the power of 6 y squared. Okay, looking at number 9. Normally, I would start working inside here, moving that a negative 2 down to the bottom. However, all of this is being put to a power of 0. Anything put to a power of 0 just becomes 1. So this is 1 minus, and now I need to worry just with this part. So I have 2a to the power of 4 to the power of 3. When I have powers and things raised to a power, this power needs to go to both parts. So that's minus 2 to a power of 3 and a to a power of 4, then raised to a power of 3. And when you have a power raised to a power, you multiply those. So 4 times 3 is 12. So I have 1 minus, I'll have a with a power of 12 on it, but I also need to do this 2 to a power of 3. 2 to a power of 3 is 8. So this 9 just simplifies as 1 minus 8, a to the power of 12. I cannot combine this 1 and 8 because the 8 is multiplying at a power of 12. For 10, once again, coefficients are going to multiply. So 8 times 5 gives me 40. When I have same bases, I add their exponents. So this is an exponent of 2. This one that doesn't have a number shown is an exponent of 1. So 2 plus 1 is going to be an x to a power of 3. My y's, I have y with a 1 and y with a negative 3. So I add those, that's y to the power of negative 2 over 20 x power of 5 y power of 6. The negative exponent says that part, just that part, needs to move, changes locations from on top to move down to the bottom. If it were on bottom, it would need to move up to the top. So I've got 40 x cubed over 20 x to the power of 5 y6, y squared. Now I can combine those y's. So I got 40x cubed over 20 x power of 5 y power of 8. And now this is going back to like what we did in question 8, where your coefficients divide. 40 divided by 20 is 2. Now, I've got x's on top and x's on bottom. The one with the higher exponent is found on bottom, so that's where the x's are going to stay, is on bottom. And 5 minus 3 is 2, so it's a x squared. Y power of 8 on bottom, there are no y's on top, so that just stays on bottom. So you get 2 over x squared y power of 8. Okay. 11 is asking us to determine whether or not these are inverses by using composition of functions. Composition of functions is where we take one of these functions and insert it in for x in the other function and simplify it down, seeing if we get to just x. If we do, we then put the other one in for x and simplify it down as far as we can. So we're going to take the g of x equation and put it in for x in the f of x equation. So we have the cube root of 5 x, but instead of x, I will use this entire equation. X minus 7 cubed over 5 plus 3. So that took care of just that x. And now I continue with this equation. So minus 3. And that is what all is under the cube root. And then outside of that, I have plus 7. So when you're working these problems, it's very important to keep your work clear as to what you're doing and when. Because now it is a matter of order of operations. What would happen first? So order of operations says parentheses happens first. So everything in here needs to happen first. Now, yes, this would take effect first, but this plus 3 minus 3, that part can cancel each other out. So I've got the cube root of 5 x minus 7 cubed over 5, and all of that is under the cube root, and then plus 7. Now, this 5 is multiplying here and then dividing by that 5. So those 5s will cancel. So I've just got the cube root of x minus 7 cubed plus 7. Now a cube root and a cube are opposites, so that's x minus 7 plus 7. Minus 7 plus 7 sums to 0, leaving me with just x. So it worked on one side, now I need to go on the other side. So I need to put this all in for x here. So I've got the cube root of 5 x minus 3 plus 7, and then carrying on with this one, minus 7, all cubed, over 5, and then plus 3. So this positive 7 minus 7, that's going to sum to 0. So I've got the cube root of 5 x minus 3 cubed over 5 plus 3. Now this cube and cube root will offset each other. So it is 5 x minus 3 divided by 5 plus 3. 5 times that divided by 5, 5 divided by 5 will undo. So then it's x minus 3 plus 3, which that will sum to be 0, so that's just x. So since both of these went down to just being x, yes, these are inverses. Twelve is very similar to 11. Now we're dealing with a square root function and then a quadratic. So once again, I'll be putting this in for x in here. So I've got negative 1/2 square root of so we've got negative 1/2 square root of, instead of x, it's this entire thing, 2 x plus 3 squared minus 6, and carrying on, plus 6 through over all of that, and then minus 3. So the plus 6 and minus 6 will undo, so I've got negative 1/2 square root of 2 x plus 3 squared minus 3. And here we've got, if I want to take the square root of this, yes, it could undo that, but I would still have the square root of 2. So I've got negative 1/2 times the square root of 2 times x plus 3 minus 3. And while those 3's would cancel out, negative 1/2 times the square root of 2 does not multiply to being positive 1. So this does not simplify to being x. If it did not, these are not inverses. Okay, 13, 14, and 15. We're solving, and these are instances of rational exponents. So I need to get what is being put to this fractional power. I need to isolate that. So here, I'm going to subtract 10 from both sides. So I've got negative 64 equals negative x minus 10 to the power of 3/2. I want this to be positive, so instead of having this negative, I'm going to divide both sides by -1 or multiply both sides by -1, however you want to do it. So I've got 64 equals x minus 10 to a power of 3/2. This is the point where we raise this to the reciprocal power. Reciprocal power being this fraction flipped. So if I flip 3/2, it's 2/3. So I do that to this side as well. That makes this side go to just x minus 10 equals 64 to the power of 2/3. Well, that's wanting the cube root of 64, which is 4, then squared, which would be 16. Okay, remember, this comes from knowing that what that fraction is saying, the denominator tells me the root type, the numerator tells me what power I want to have. So I'm taking the cube root of 64, and then I want to square it. And that's where that 16 comes from. Then I need to add 10 to both sides. I get x equals 26. For 14, again, I want to get this part here that has the exponent on it, get that alone. So I need to add 3 to both sides. So I've got 8 minus 2x to a power of 5/4 equals 32. And then I'll need to raise both sides to the reciprocal power. 5/4, the flip of that is 4/5. So I need to raise 32 to the power of 4/5. So that is saying, what is the 5th root of 32, then raised to the power of 4? So on the left side, I have 8 minus 2x equals the 5th root of 32 is 2. 2 to the power of 4 is 16. Now we're just solving for x. So I subtract 8 from both sides. So negative 2x equals 8, and then divide both sides by negative 2. I get x equals negative 4. Last one on of these, I have 4x to the power of negative 3/4 plus 10 equals 21/2. So I need to subtract 10 from both sides. So that's 4x to the power of negative 3/4 equals, if I want to subtract this 10 from this fraction, I would need to have a common denominator. 10 is the same thing as 20 over 2. So I have 21/2 minus 20/2, leaving me with just 1/2. Now, the only thing that's being put to this power is the x. The 4 is not. So I need to divide both sides by 4. So I have x power of negative 3/4 equals 1/2 divided by 4 is going to be 1/8. And then I raise both sides to a power of negative 4/3. Left side will give me just x. Right side, this negative exponent on a fraction says to flip that fraction. So that is 8 to a power of 4/3. Or it is wanting to know the cube root of 8, then raised to a power of 4. The cube root of 8 is 2. 2 raised to a power of 4 is 16. So I have x equals 16. Our last problem here is talking about this formula that can be used to determine the volume of square prisms. So we have S equals the square root of V over H, where S is the length of each side of the base and H is the height of the prism, and V would be the volume. Part A wants us to write an expression that we could find the height if we knew the side length and the volume. So it's wanting us to rewrite this equation having solved it for H. So if I've got S equals the square root of V over H, and I want to solve for H, the first thing I need to do is square both sides. So I have S squared equals V over H. To get H out of the denominator, I need to multiply both sides by H. So I have H S squared equals V, and now to get the H alone, divide both sides by S squared. And you get H equals V over S squared. So this is the equation that we'll be using for part B. Part B says it wants to know what is the height if the side length is 8 and the volume, the V, is 192. So I have H equals 192 over 8 squared. Well, 8 squared is 64. So I have H equals 192 excuse me. I have H equals 192 divided by 64. And 192 divided by 64 is 3. So the height here, H equals 3 centimeters.